Now we are studying the components of a vector, which I told you last week. The vector is an important part in the Physics 111. Here we have vector C equals vector A plus vector B, which is addition. In figure 14b, you have on the same page A equals vector C minus vector B. And direction of the vectors are very important. Now look for the next figure. You have 1.5, the same page. Here the displacement vector is r and the vector components are x and y. Just to show you the pictures you have or the figures you have in your book, I just enlarged it. You can look into that. Addition and subtraction, as I mentioned in there. Here r is the resultant vector and you have x and y, x-axis and y-axis. You can see that there are two different vectors. This is horizontally on x, this is vertical on y, and this is your resultant vector. Okay. We are choosing a vector at random, which is vector A, and its vector components are ax vector, ay vector, which is shown in this diagram which I showed you. You can have a reference also for figure 1.18, page 13. This is a clear view. You can look into this, which I mentioned to you guys. The next one shows you the x direction, y direction. You have ay and ax, and here the unit for the magnitude is 1 unit, and this is shown in this figure here. In the figure 1.19, page 13, the vector components are shown here. For vector A, it is ax and ay. Ax is the component on the direction of x, ay in the direction of y, and again the unit for the vector magnitude wise is 1. Now the direction is very important. Both the direction for x and y is positive. Now we'll talk about addition of vectors using component method. And you know by this time, I believe, in the direction of x, we are resolving, let's say you have a vector C, which is the resultant vector. You have a single vector A, B, and A and B, as you see. Ax is in the direction of x, which is x component. Bx is B component, which is in x. And in the direction of y, you have cy, which is ay plus by. You should have always the arrow on top of these alphabets like C, A, B, C, A, B. We'll use the Pythagorean theorem to figure out the resultant which you are interested in is C. C is under root cx square plus cy square. What I told you guys is very much clear in this picture here, this figure. We have all different type of triangles and vectors shown in this. You can look into that yourself. Now once we find the resultant as C, we also have to figure out the angle. Theta is tan inverse cy over cx. Again, theta will be tan inverse ay plus by over ax plus bx. Please go over also example 8, page 14, finding the components of the vector, which is figure 1.20, page 14. This ends your chapter 1.